Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the diploma questions of the unit atomic physics, and today we completed that unit with that diploma questions. So let's start with the first diploma question. The question says the atomic models developed by the Rutherford, Dalton, and the Thomas are respectively what? So we have to be like which model created by the Rutherford, Dalton, and the Thomson. So they have some MCQ question, and we know that the Thomson made the model called the Asenban, where they're doing the like putting light structure and tell this is like a atom structure, and this has the positive charges and the negative charges. So that was experiment by the Thomson. The Rutherford, we know this is a experiment, planetary experiment where they do the orbit thing and tell that nucleus is discovered by them. And you don't study about the Dalton's model, but Dalton's model is the billiard ball model. This is the model of the Dalton, and for this type of thing and respectively, and the answer should be the A. So these are the three models developed by the Rutherford, Dalton, and the Thomson respectively. So you have to know about the Dalton's model too. And we have a next question over there. The question says one intermediate result for the discovery of the cathode ray particles was that the theory of the atom was revised to a theory that hypothesis that. So the Dalton has the four theories. The two of them are incorrect and two of the other correct. So which of the following are the revised theory after that? So the cathode rays are basically the negative particles, negative charged particles, and the theory of the atom, which was described by theory of this, is the and is visible sphere. No, the atom exists in the probability clause. That was no. The D part, which is says an atom contains a negatively charged particle, is the right thing, because the C part says an atom is mostly made of the empty space. So that was the correct thing doing by the Rutherford. But that thing that the negatively charged particle, that was the revised theory which hypothesis by the discoverer of the cathode ray particles, that they are the negative thing. So that's the answer for that. Next question we have. Next question says a negatively charged particle travels undeflected through a mutual perpendicular electric and the magnetic fields at a speed of 3.8 into 10 raised to a 5 meter per second. The magnetic field strength is 470 meter Tesla. The electric field strength we have to find, which has been in scientific notation of like this, and we have to find the value of A, B, C, and D. This is a calculation based question. They said this is undeflected, so your net force goes to be 0 in that case. And they said the mutual perpendicular of the electric and the magnetic fields, which means your electrostatic force is equal to your magnetic force. And you know this is equal to the Q times the electric field, and this is equal to Q times V, the magnetic field. From here, the Q and Q is cancelled out, and we have to find the electric field, where V is given to us, which is 3.80 10 raised to power 5 meter per second. And the magnetic field is also given to us, which is 470 meter Tesla, which is 470 into 10 raised to a minus 3 Tesla. When you find this, when you calculate this, you get to power 1.79 in scientific notation into 10 raised to power 5 volt per meters. So this is the answer for this answer, and we want for A, B, C, and D value. So it's 1, 7, 9, and 5. So you get the easy type of questions from the model of the atom part, which have a Bohr model. Bohr model, we have the questions like we studied. Okay, we will do that questions. So that's all the questions you get. And yeah, so let's move on to the next one. The question says a charged particle enters 91.0 meter Tesla perpendicular to the magnetic field at a speed of 7.70 10 raised to power 6 meter per second, and it goes on into a uniform circular motion. The charge to mass ratio of the particle is given to us, so we have to find the radius. So they don't mention that we have to find the radius of this, which is r. We have to find that. And that was the do you know that the charge to mass ratio when Thomas do, they do the two steps. The first step is when they both are there, the electric field and magnetic field both are there. So this type of question we have, this is the first step. Second step, they do turn off the electric field and they do the magnetic field only, which goes to a circular motion thing. That was the second step of that. So this involves that type of question where we can find the r. So we have a circular motion. which is circular force, is equal to the magnetic force. Circular force is equal to mv squared upon r. This formula is not on your formula sheet, so you have to be memorize this thing. And this is qvb. And from here, one v is cancelled with another v. We'll have fit mv upon r is equal to q times magnetic field. We have to find the r, so we have to isolate the r from here, from where we get the v upon that m goes down, which goes like q upon m type thing, because we have charge to mass ratio, so we take it as q upon m, and we're left with the magnetic field. So from here we can put the values in. So speed is 7.70 10 raised to power 6 meter per second. Charge to mass ratio is 1.42. So it's 1.42 10 raised to power 9 coulombs per kgs. And this is given to 9.0 in 10 raised to minus 3 Tesla. So when you find this, when you calculate this whole thing, you get about 0.0596 meters. But you want this in centimeters. So this is not like a nice thing. So you can like do other thing and get into centimeter with this shorter thing. So you have to multiply this by 100. When you multiply this, you get about 5.96 centimeters. And this was the answer for it. That easy things. That two steps are very important, which the Thomson do with the circular motion with the electric force. So you have to know this about. So next question we have. This is from the atomic spectra thing, which is done by the Bohr model. So the Bohr model does the three things: the continuous spectra, emission spectra, and the absorption spectrum. And we have the four situations, you can say, and we have to say that which is the which number, that continuous, emission, or the absorption. First one is the light emitted from the neon tubes from store signs is A. So that light which is emitted from neon tubes, that thing is called the emission, because we involve the emission thing in this. We do the emitted thing in this with the neon tubes. When the tubes are involved and when the electricity can be also be involved in that step, that is called the emission. So first one is the 2 for that. Then we have a light emitted from a hot black metal. So when the hot black metal is clear, and when we do the white light thing and they do the spectrum, we involve the black metal. We do the hotting this, hot that thing, and then we do the experiment. There's another way to do the continuous spectrum thing. So this means this is a number 1. Next one, the emitted from a sun's core after it has passed through a cold atmosphere. When they mention the cold atmosphere, there is nothing that electricity, nor we use the other thing like a heat and all. We do a cold atmosphere, that was absorption thing, because absorb that thing. So which means that this is your number 3. And the last, the light emitted from a hydrogen gas tube after the current has been applied to it. So they mention the keyword, which is a hydrogen gas, which means they do the emission again with the tubes and electricity. So they will go to the 2 again. So 2132 is your answer for it. So this is a type of thing that we don't do in like practice questions when we do. That this type of questions is like a very like a nice way to tell about the spectrums. We have a simple way in the practice question when we do it, but this was the nice way to like confuse you somewhat, but you have to know some keywords from that in the spectrum thing. So that was the from the Bohr model of the atom, which is the atomic spectrum. Next thing, we have again the Bohr model that they do the quantized thing. That things can be like quantized, and they do the electron thing, emission, absorption, that thing. That's the question from that. So the question says, the diagram is going to be with the energy level diagram, and we have some energies too. The electron is located at the n is equal to 5. So electron is over there, and it drops to a lower level and emits a photon with an energy of 9.6 10 to minus 19 joules. We have to find the lower level. So there is like a 1 to 4, there is a 1 level which did drop down. So we have to find that final energy thing. Basically, firstly, we have to start with we have a n is equal to 5, we have given that thing. But we have to do some conversion in this. What conversion? That joules should be in EV, because that all the energies given to us over there are in EV. So we have to be in that thing also in EV to get the answers in EV. So we have to convert this, so we have to divide this. So 9.60 into 10 raised to minus 19 joules divided by 1.60 10 raised to power minus 19 joules again, which is into 1 EV. So joules cancel, you get in EV, which is about 6.00 EV approximation. And that thing, they tell this is a photon with an thing energy, so this is your delta E given to you. And you know your delta E is equal to the final minus initial with that absolute thing. But you have to find the final thing. So that final thing is equal to delta E plus E EI. So you have to know the final. So delta E we have 6.00 EV plus what is the initial thing is 5. So we have to do the E5. So at E5 we have a 15.4 EV. So we have to use this thing. So 15.4 EV. So when you calculate this, you get your EF about 9.4 EV. So now you have to do some ranges that 9.4 is lie on which of the following n. So 9.4 is approximately like the 9.40, which is basically the n is equal to 2. So your n is equal to the 2, which is the B part. So that's the simple kind of question. You have to know this formula. You have to know that all the things should be EV because that shells are always be given in EVs. That energies of the every n is given to an E. So that's you have to do, and this is your answer n is equal to 2. So next thing, we again from the Bohr model, that's some calculation part we done. The question says an electron in the Bohr model of the hydrogen has a radius of 2.59 nanometers. The orbital speed of this electron expressed in the scientific notation of this. So we have to find the optical speed, which is the V we have to find. So to find this, we have to know the nth thing. So this is the electron can be, then we have involving the radius in this thing. Again, this is type of the thing when the Bohr model use the hydrogen thing and they do the electron thing too in this, which they involve two things. Firstly, they involve the electrostatic force, and the electrostatic force goes to be the again your circular force. That thing is related to that because we have the R, we have to find optical speed. So that's the another thing can be defined by the Bohr model. The Thomson model defined that the two things that the electrostatic force and the magnetic force is equal when the net force is 0. Then they do the magnetic force with the circular motion. But the Bohr model do the another thing, do the third thing, with their circular force is equal to the electrostatic force. And we have to take the mass of the in the electron in this. And that electrostatic force is not used as the Q times E. We have to use the another thing because Bohr model there was the another equation that because they involve sometimes the two types of charges. So we use that thing, which is QP and QE. They involve the two things always, so we have to use that two things in the basically that QP and QE is always equal because we already do all the electron in this, so we take it as a Q square this thing. So from here your this was the R square, so 1R is cancelled with 1R and you have to find the speed, so we have to isolate that things, which is equal to kq square upon R and the mass of the electron because the electron is in the Bohr model and the whole square. So K is 8.99 to 10 raised to 1 minus 9 Newton meter square C square, and this is 1.6 to 10 raised to minus 19 Coulomb square. Divide this by the R, which is 2.59 into 10 raised to minus 19 meters, nanometer value of this, and have a mass of the electron. And this whole thing should be the square of that. So when you solve this, when you calculate this big term, you get dot product to be square root of this. You get 3.1 to 10 is to power 5 meter per second scientific notation. So your numbers are 3, 1, 2, and 5. That's your answer. You get these type of questions. These are long questions in the numeric basically because we have to be in the right scientific notation and we have to be in the right significant digits in that. So that's for the Bohr model, and that will do this formula when. Have to know this formula with the circular motion. Next, we have some theory-based questions, like where we start the nuclear physics, the second part, with some theory thing, some more theory part in that. So we have that questions. So first question says that isotopes have. So isotopes, the definition for isotopes is very important. We know the notation of isotopes, A and Z. That two things. That is a notation of the isotopes. And what are the isotopes? You have to know this, that they have the same number of protons and the same number of neutrons. No, this is not there because they have the same number of protons, but they should have a different number of neutrons. So this is not your answer for that. They should be the same. So this should be right. And the next one, B, is wrong because they said there's a different number of protons. So this is wrong thing. You can't do like this and this not true. The C part is right, where they said the same number of protons and a different number of neutrons, which is the right thing. The last one is again wrong, which are both different. So we have a C part. So C part is right. This one. We have to know this. They have the same number of protons and a different number of neutrons. Next thing, next MCQ. Which of the following is not a true about the strong nuclear force? So strong nuclear force is a very important thing, and we have to say that which is not the right thing, which is not true about that. So basically, first one is A, that it is always an attractive force. Yeah, this is very attractive force always. This is a true about that. It acts only between the neutrons. No, that was the wrong. So B is the option because they don't attract with any neutrons. They can be attracted with the nucleons. So nucleon is the main thing is, but not the neutrons. They do with the nucleons. So the B part is your option. The C says the strong only when distances are extremely short, which is right, and is the strongest form fundamental force, which is also right for this. Except B. So B is your thing because that was not true. Then this thing. Then we have some questions from the decade thing when electromagnetic alpha decade, beta decade, we do that topics. The manganese 50 undergoes alpha decade, the daughter nucleus would be. So the manganese, which is 50, which is denoted by the Mn, and have a 50 and atomic number of 25. Do under the alpha decade, which is 4 and 2, plus 50 minus 4 is 46, 25 minus 2 is 23, and this is a viridium. So this is a viridium 46. So the answer is D. You get this type of question, that alphabetical question format. You get one of the question for sure in your diploma or examination. So this is a very important question, not in the written, but in like this type. Like the next thing, the radioisotope went through a beta negative decade and resulted in the daughter nucleus in a ASEAN 75, the identity of the parent nucleus. So there is a backward thing again. So we have that the product is ASEAN, which is 75, and we have a 33. And this is in the beta negative case, so I also have the product as in this and the anti-neutrino. We have to tell that thing, which is that what is the reactant thing. So 75 says a 75. When we do forward, that from reactant to product, we do in the beta negative we do plus 1. But we do backwards, we do minus 1, which is 33 minus 1, which is 32. At 32, you have a germanium, which is the GE. So germanium 75, which is C option. So that's how you can have the questions about that beta decay and all the things. How to take care of that things. Next question is from like your half-life questions, which is again very important topic because sometimes when you have to find the n and all things, we have to involve the logarithm in this, as we discussed in the practice questions. But in this, we don't do like this. We have to find some percentage thing. This is another type of this type of questions. Question says cobalt-60 is the common radiation source used in the cancer treatments. The half-life cobalt-60 is 5.27 years. The cobalt-60 nucleus decays by emitting a beta-negative particle and a gamma photon. There's extra information given. So we have to basically find the percentage of the cobalt-60 remaining after 15.6 years is in percentage. Basically, when you do about the percentage, you know the formula is this. Half T upon T half. They're given to you half-life, T half, and they also given you the T2. Basically, what you have to find when do you get out of the percentage after at that time. So you have to find the n upon n. What do I do? That n is over there. We do n divide that thing and we find that the ratio thing n upon n. So we left with half, and we have t divided by t half. So t and t half is given to you. So t is 15.6 years, and your this is a 5.27 years. So years and cancel, and where's 5, I have to like solve the half raised to power 15.6 divided by 5.27. When you do this, you get about 0.129 at the end. When you go from the percentage to the anything that without percentage, you do divide by 100. But you go from do to a percentage, so you do multiply by 100. When you do this, you get the percentage about 12.9%. So that's your answer for that. That's another way of the half-life quotient you get in your examination diplomas. In that. Okay, the next question says a quantum particle has a mass of the 8.77 10 to minus 28 kgs, which is equivalent to the mass of the MeV square. So we have to find some conversion we have to do in MeV square. So how can you do that? To do that conversion, we have a mass, which is basically the particle mass, which is your defect mass. So you know that E is equal to defect mass C square. This is already in kgs. So 8.77 10 raised to power 10 raised to minus 28 kgs. 3.0 10 raised to power 8 meter per second square. You get your energy from here of about 7.884 into 10 raised to power minus 11 joules divided by the EV, because we want in MeV square. So we have to firstly turn it into the EV. We divide by that thing which is in joules. Joules cancel out. You get your E of about 4.93 10 raised to power 8 EV. Have to convert this in MeV, so divide this by 10 raised to power 6 EV. This cancel out. You get about 493 MeV, and you have to do the per C square. That we calculate with the per C square. That's what to do, and that's your answer for this, which is 493 MeV square. That thing is equivalent to that thing when you have to divide by the C square. So let's move on to the next question. Again, the theory-based question from the Crotts and the standard model. If the particle with a Crotts combination of UDD decays into a particle with a Crotts combination UUD, what else is emitted? So what's happening? UDD, it decays to UUD. So what else the particle is given? So basically, when we do that topic, we also involve some beta negative decay and the beta positive decay in this. That when that D is converted to U, that D thing is converted to a U, some beta decay is happening. If when that D converting to U, we have a beta negative decay. That's all we have to know for this. For beta positive decay, UUD converted to UDD. Like U goes to D, and they involve the electron positive and the neutrino. But in this is a beta negative decay happening. So this becomes the negative, which is electron, plus the anti-neutrino, because this is your beta negative decay. So that's all thing, that not be the different thing, that all from your booklet, all from your topics we discuss, that we have to know. So C part is your option for that. That's the right thing. You have to know this, that how when this goes to this, which decay is happening, beta negative or beta positive. This is beta positive. So with that example, we end with this unit. So this unit is fully ended, and we completed the course too. That we completed all the topics of this course, which is Physics 30 or Grade 12 Physics. So now we are on the end. We are end this unit. So what's next in that? So we have to know something about this, that what's next after that. So we still have many unanswered questions with the standard model. So when we end that topic of the standard model, and when we do the explanation thing, that all thing, so we quickly I will discuss that whole, that what does the gravity fit in the standard model, what is the dark matter, why is it mostly matter not antimatter, because we discuss the antimatter thing in that. We use antiparticles in that. So why the mostly is a matter, not antimatter? That all questions are there. So all some general overarching questions we had to be answered in physics. For example, when the questions of the space time, we know the space, we know any direction, comes to time, we move forward. So what is unidirectional? If there is a directional thing, so what is a unidirectional thing? So that's another question. Einstein's theory, those related to Einstein's theory we have, that what type of thing we do the quantum mechanics to explain the electromagnetic nuclear and the weak nuclear interactions, but nothing to explain all the interactions together when we could gather all the fundamental forces. So what will happen? To answer to those questions keeps the entire discipline of the physics running and the progressing. We always continue to answer questions and add in answering the question and we generate the new question that will need to be answered in physics. There will never be to end-to-end science, only to goes asking and answering the questions. So that's the core thing of the physics, that we always have to be doing questions, asking questions. All what is left to say is congratulations, and we finish all the required material for physics 30 or grade 12 physics. And with that, now we finish the program of studies for the high school study physics. So high school physics is completed over there. We done grade 11 physics, we done the grade 12 physics. So that was the end of that. However, your journey is just begin. In high school, we have the do some surface stretch. We do some like a very minimal droplets. We don't do the deep of physics. So for next step to the marriage of physics with the calculus, I can take it from there. So calculus thing. So calculus is after the math 30-1, which is a grade 12 math. So calculus is very important and they connect it to the physics again. For those who are going to physics for engineering, your journey will continue. For those who are with this for the last physics course, will miss out on some adventures in the physics, and but I understand and respect your decision and wish you nothing but the best in my path that you will take. So that's all you have to do in this. That's the next thing. If you completed the physics high school, so that's the end of the physics course. And if you have to approach, if you take the physics in future in university level, so you have to do in deep depth, more depth in physics. As I over there that we do physics and calculus, physics and math, both hand in hand. So with that, we completed the physics and we completed the grade 12 physics too. That was the end of the physics. So we end that topic. Now you have a diploma. You have a diploma on 22nd June 2026. And we do some review of all the topics again before this 22nd June. So you get the review videos after that. We review lessons and some extra questions again. So this is all for this lesson. I'm Mr. EduVibe, learn smart not harder. Please like and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till this, get it with EduVibe.